Hey you guys, this is Uniform Notes number 2. We're on part 2 of related rates. Same FLT. So, provided that you have the equation and given values, you should be able to use that concept of related rates to find what they're asking for, right? So here we go. These problems that I'm about to show you requires a little bit more thought. Doesn't mean that it's difficult. It just requires a little bit more attention to detail, okay? So just keep that in mind as we go through. Again, you will need a calculator, so make sure that you have that in front of you, okay? Okay. Feel free to take a picture of this or to write it down, okay? But I'll give you a second. Press play whenever you need to. Okay? So a good first suggestion is to highlight some important pieces, okay? Feel free to highlight with me. So we have a cylinder, and the height of the cylinder is increasing at a rate of 6 feet per second. The volume is decreasing at a rate of 171 cubic feet per second. At the instant when the height of the cylinder is 6 feet, the volume is that much. And then here's our question. What is the rate of change of the radius? Okay. Now they were nice enough to give us an equation. Okay. So a good first move is to jot down everything that we know. Okay. We know that the height of the cylinder is 6 feet. We know that the volume is 1,254 cubic feet. What else do we know? We know that the height of a cylinder is increasing at a rate. So a rate would be d over dt. In this case is dh over dt. And since the height of the cylinder is increasing, the derivative has to be positive 6 feet per second. Hopefully you guys are a little bit more comfortable applying that idea there, okay? So now we know that the volume is decreasing at a rate, so that's d over dt of v, volume. Since the volume is decreasing, the derivative should be negative 171 cubic feet per second. Okay? All right. Now they also tell us that v equals pi r squared times h, okay, which is the volume of our cylinder here, all right? So let's take care of this orange part. What are they asking for? What is the rate of change of the radius? So remember, rate of change just means d over dt. And we're trying to find the rate of change of the radius, so we're really finding dr over dt. This is the ultimate goal right here, okay? So since they were nice enough to give us that equation, we just have to take the differential. So here we go. The derivative of v is just 1, but the differential is with respect to v, okay? Here we have a product, pi r squared times h, okay? So what's going to be required? Right? We have to apply the product rule. So here we go. It'll be the first times the differential of the second plus the second times differential of the first, which is 2 pi r, but with respect to r. Make sure that that made sense before you move on, okay? That's probably the most challenging part. All right, here we go. What do we do after we find all of our differentials? We divide them by what? We divide them by dt. Okay, so keep in mind, this is what we're looking for, dr dt, which is this highlighted part right here, right? So what that's going to imply is that they will give us all the other values either directly or indirectly. Okay? So here we go. I personally like to plug things in first before I isolate. Some people like to isolate first and then plug in. There really is no difference unless you're doing it incorrectly, right? Okay, so here we go. We'll go from left to right here. dV dt. They told us that was negative 171 cubic feet per second. I'm going to ignore the units, okay? And I'll show you a way to kind of handle that. Okay. Equals pi r squared times dh dt. Okay, so r in this case is what? Right? Notice over here we don't have anything for r, so let's come back to that, all right? dh dt is positive 6. Okay, h is 6 feet times 2 pi. Again, we don't know what r is. Actually, let me scoot this over. Okay, 2 pi r, we don't know what that is. And dr dt is what we're looking for. So I'll just write out dr dt. But here's the issue. We should be able to figure out every single value except dr dt, but we're actually missing r. So think about it. How do we find the radius, right? So you kind of have to find the clues. They give it to you, but not directly here, okay? So we know that volume is pi r squared times h. And we know that at a particular moment where the volume is 1,254 cubic feet and the height is 6 feet, shouldn't we be able to figure out what r is, right? So you kind of have to hunt for your clues here. So let me get rid of the feet here so that we don't make it too messy. So here is just a case of solving for r. So we're going to go ahead and divide by the 6 and the pi so that they can cancel out. And then r squared will equal whatever that is. And then r will equal just the square root of 1,254 over 6 pi. Okay, so I'm going to give you a second here to type that out while I do it as well. What I encourage you guys to do is to group the 6 pi. Okay, if you don't, you might get a different value. So here we go. We have the square root of 1,254 divided by parentheses 6 pi. Close it. Okay. Now I'm getting 8.156394192, and it keeps going. Okay. So the rule of thumb generally is to round to 3 decimal places for your final answer. But notice how r is not the final answer here, okay? So what you got to do is you kind of have to keep that value. All right? So that's going to go in here and here. All right? Now, it generally works if you keep 5 decimal places, okay? You don't want to round intermediate answers or answers in the middle, but if you're going to round it, keep at least 5 decimal places so it doesn't ruin the final answer here, okay? So here we go, just so that you guys can follow along with me. I have negative 171 equals. I'm going to go ahead and input this and then this separately into my calculator, okay? Let me go ahead and do that real quick. So I'm going to do pi times my previous answer squared. And if you want to do previous answer, you could do second and then that negative symbol for ANS. Okay. times 6. Okay, that should give you 1,254 plus, now 6 times 2 pi times our previous answer, or 2 answers ago. You just have to press up and up to highlight over it. You should get about 307.4888169 dr dt. Okay, so here we go. We're going to go ahead and subtract the 1254 to the other side. Negative 171 minus 1254. You'll get negative 1425 equals 307.4888169 dr dt. And then we're going to go ahead and divide that guy. Now, you don't need to show the computations, but I'm showing it to you guys so you can kind of follow along with me here. So divided by 2 answers ago, you should get dr dt equals, and since this is the final answer, I'm going to round it, negative 4.634. Okay? On the AP exam, they tend to ask you what the units are, okay? So radius is measured in just the units. So in this case, they used feet. You wouldn't put feet squared because it's not area, and you wouldn't put cubic feet because it's not volume, okay? Time in this problem is measured in seconds, so there you go. So what this is saying is that the radius is decreasing, since the derivative is negative, at a rate of 4.634 feet per second. A lot of computations, you guys, all right? But let's practice, okay? Here we go. Here's part B. Write it down, then press play whenever you're ready. Okay, so here we're dealing with a slightly different object. We're dealing with the volume of a sphere. Here, the volume of the sphere is decreasing at a constant rate of 1/16. When the volume is 7 cubic centimeters, here's the question. What is the rate of change of the radius? Okay, they happen to give us an equation to work with, okay? So a lot of information, but let's jot this one down here. We know that the volume of a sphere is decreasing at a rate, so that's d over dt, and that's the rate of the volume, so dv dt is decreasing, so negative 1/16 cubic centimeters per second. We know that the volume, V, of the sphere is 7 cubic centimeters. And then they tell us that V equals 4/3 pi r cubed. And they're asking us what is the rate of change, so d over dt, of the radius. So they're asking us what dr over dt is. So this is our goal, all right? Okay, so here we go. We have our equation. Let's find the differential. That'll be dv equals 4/3 pi is just a coefficient. The derivative of r cubed is 3r squared, but with respect to r. And then we divide our differentials by dt. At any point, you guys, if you feel like you know how to do it, pause it and move ahead and then play to check your answers there, okay? You don't feel like you have to wait for me. Okay, so we're looking for dr dt, which is this right here. So that means we should be able to get information about dv dt as well as r, okay? So here we go. We know that dv dt is negative 1/16 4/3 pi times 3. Now, they don't explicitly give us r, and we need dr dt. So how do we find r, right? So they do give it to us, but indirectly. We kind of have to find it ourselves. So think about how you would find it here. And then press play when you're ready. Okay, so you would have to go back to your original equation here. V equals 4/3 pi r cubed. If you know the volume, which is 7 at this moment, you'll be able to figure out what the radius is at this moment, right? So go ahead and solve for r there, and then press play when you're ready, all right? So here you can do this in many different ways. I'm going to multiply by the reciprocal, so I'm going to multiply by 3/4 pi so that I can cancel out the coefficients. This is going to be 21/4 pi equals r cubed. And then r will be the cube root of 21/4 pi. Okay, there's no plus or minus with cubics, so watch out for that. And plus, you got to have a positive radius, okay? Okay, so cube root, you can do in two different ways. You could either do 21/4 pi all to the 1/3 power, or you could just find the cube root button. The cube root button is actually math. So right below the alpha button is math. And if you go down to number 4, you'll find that cube root there, okay? But if you don't want to remember that, just raise everything to the 1/3 power, and that should work too. And again, make sure that you guys are grouping your 4 pi. I'm going to go ahead and type this in, and you guys should too. Press play whenever you guys are ready. Okay, on my end, r equals 1.186687798. Again, do not round the answer because it's not the final answer. So that is going to go here. Okay, so what I'm going to do is I'm going to take that r, I'm going to square it. Then I'm going to multiply it by 3. Then I'm going to multiply it by a pi. Then I'll multiply by 4, and then I'll divide by 3. So you learn to kind of do everything all at once. You should get about -116 equals 17.69631409 dr dt. Okay, so last step here is to divide that value there. You should get -116 divided by the previous answer. You should get -6.555, and this is where we want to round to 3 decimal places, okay? So there's your answer, okay? In terms of units, dr dt, that should be centimeters per second. You wouldn't do centimeters squared or cubed because it's not area and it's not volume, okay? This implies that the radius is decreasing, since it's negative, at a rate of 6.555 centimeters per second. Okay. You guys can manage that one. Okay, let's jump to the last example here, example 2. Okay, go ahead and write it down. And press play whenever you're ready. Okay, so here we go. We have the volume of a sphere that's increasing at a constant rate of 3,258 cubic feet per second. I should highlight the whole thing. So specifically at a moment where the volume is 4,052 cubic feet, what is the Okay, let me highlight this. Here's the question. What is the rate of change of the surface area of the sphere? Okay, they give you some clues here. They give you two equations. So sometimes you're dealing with multiple ideas here, right? But nothing has changed. So here we go. We jot down what we know. We know that the volume of a sphere is increasing at a rate. So a rate means d something over dt. Since the volume of a sphere is increasing at a constant rate, that's dv dt. And increasing implies that it's positive, 3,258 cubic feet per second. Okay. The second highlight, the volume of the sphere, so just V, is 4,052. Now what they're asking for the rate of change. So rate of change just means d over dt of the surface area. So I'll just use S for surface area. This is what we're looking for. Okay? So this one gets a little tricky because they give you two equations here. We have V equals 4/3 pi r cubed, and then S equals 4 pi r squared. So how do you know what to deal with what, right? Well, the ultimate goal is to get ds dt. So which one are you going to take the differential of, right? So initially we should start off with this one because we want to end up with ds dt. So here we go. The differential of of s is ds. The differential of 4 pi r squared is 4 pi times the differential of r squared is just 2r, but with respect to r. Okay, we divide our differentials by dt. Okay, so far so good. So the good news is ds dt is already isolated, so we don't have to move anything around. But do we have everything that we need, right? So, for instance, I'll leave this here. We have ds dt equals 4 pi times 2r times dr dt. But from what I've written down, I don't have my r and I don't have my dr dt. So what the heck, right? So in order to find ds dt, I need to know what the values of r and dr dt are. Okay? That was a lot of r's. Okay, so again, they give it to you, just not directly. You kind of have to find your clues here. So think about what you would do here. Pause if you don't want to know the answer just yet. And then play when you're ready, okay? So here I know that the volume is 4,052. So what I can do is, well, if the volume is 4,052, that should be enough for me to figure out what R is. Okay? So go ahead and figure out what R is. And then press play when you're ready. I'm going to compute this myself. So 4,052, we're going to multiply by 3 and divide by a 4 pi. Make sure you group the 4 pi. And then we're going to go ahead and cube root that answer. Now, if you did it correctly, you should get about 9.8899 something. Okay, again, we're not going to round that. I'm keeping that value in my calculator, even though I didn't write it right here. So now I know R. But what I'm missing is dr dt. Okay? So think about it. What have I not used yet, right? Notice I haven't used this yet. And the only way to use this dv dt is maybe if the differential of this equation. So there are a lot of layers to this here, okay? Here we go. So if I know that v is 4/3 pi r cubed, The differential would just be dv equals 4/3 pi times 3r squared dr. Okay, we'll divide our differentials by dt. Okay, so take a look. I need to know what dr dt is in order to get ds dt. Okay, so dv dt is 3,258 equals 4/3, I'll put the pi up here to make it easier, times 3. Now r, I just figured out, dr dt. Okay, now there are a lot of computations here, so I need you guys to take your time. I'll write it out so that you guys can follow along the way. What I'm going to do is I'm going to take that radius that I had, the 9.889-ish, I'm going to square it, then times 3 times the 4 pi divided by the 3, okay? So square times 3 times 4 pi divided by the 3. So over here, if you're on the right track, you should get about 1,229.127915 dr dt. And then you divide that sucker. So 3,258 divided by your previous answer. So dr dt comes out to a positive 2.650-ish. Again, we're not going to round that because that's not the final answer, okay? So that right there is going to go here. Okay, so here we go. I have 4 pi times 2 times the radius. You might have to toggle up on your calculator. It's that 9.889 number. Press enter. Times dr dt, which was that 2.650 number. If you did it correctly, ds dt comes out to 658.851 rounded. Okay, now in terms of units, so first off, if you didn't get 658, go back and double check your work. Don't move on until you get that, okay? Okay, the units, think about it. S stands for surface area. How do we measure area, right? Area is always measured in some type of square units. So this is going to be, what do we use here? Feet. So this will be square feet. And time here is measured in seconds. So it'll be square feet per second. This means that the surface area is increasing because the derivative is positive. The surface area is increasing at a rate of 658-ish square feet per second. So we had to use 2 formulas to get the rate of 1. Okay? Again, it's a scavenger hunt. Okay? They don't spell everything out for you, but they give you enough information to be able to find it. Okay? So let's try one more, and then I think we're all good. Okay, here's the last one. Part B, the volume of a cube. Okay, go ahead and write it down. Press play whenever you're ready, all right? Okay, here we go. So the volume of a cube is increasing at a constant rate of 547 cubic centimeters per second. This is way better without the gardening noise in the background, right? At the instant when the side length of a cube is 6 centimeters, what is the rate of change? I'll use a different color here. What is the rate of change of the surface area of a cube? Round your answer to 3 decimal places, right? Okay, so let's jot down what we know. We know that the volume of a cube is increasing at a rate. So rate means d over dt. And this is the rate of the volume, so dv over dt. And will it come out positive or negative? Since the volume is increasing, the rate should be positive 547 cubic centimeters per second. Okay. Somewhere in the middle says the side length of a cube is 6 centimeters. I'll use S for side length of a cube, 6 centimeters. Then they're asking you, what is the, you know what, let me use L so that we don't get confused. We'll use a fancy L. The peak highlight says, what is the rate of change? So rate of change, again, means d over dt. The rate of change of the surface area, so I'll use S for surface area of the cube. So this is what we're looking for, okay? Notice here they don't give you the equation, okay? So sometimes they do, sometimes they don't, all right? There are basic ones that you should know, but we'll talk about that later. How do you find the surface area of a cube? Feel free to Google it or just to think back. I'll give you a second to do that and press play whenever you're ready. Okay, surface area of a cube. Okay, if you think about it, if you're gift wrapping this cube, okay, let's call this, and we know all the sides are the same, we'll call it L, L, and L. The top and bottom will be L times L, okay? That'll cover the bottom and the top. We have two of those, okay? So another way to write this is 2L squared. Now, if you think about the four sides, one of the sides here is going to be L times L, which is another L squared. But we have four of those sides, front, back, left, and right. And then we add up all of them. Okay? So the formula is actually 6L squared. You might have seen that in your Google search or wherever you searched it, okay? But that's basically the logic behind it so that you guys understand where the formula comes from, okay? So 6L squared. All right? There you go. So we take the differential, ds equals. Now you can leave the 6 to the side or you can deal with it head on. It's kind of up to you. The derivative of 6L squared should be 12L, but with respect to L. And I do a little cursive L so I don't confuse it for a 1, okay? I'm going to divide our differentials by dt. Okay, and what I'm looking for is ds dt, which is right here. It's already isolated, so that makes it a little bit easier. So ds dt will equal 12 times the length, which is 6, times dl dt, which they did not give us. Okay, but they did give us dv dt. So the only way to incorporate dv dt is if you're dealing with the volume of the cube. This is another case where you have to use two formulas, okay? So the volume of a cube is just, well, I'll let you guys Google search that. Try to find it out yourself. Don't wait for me. Okay, volume is just length times width times height, or in this case, length cubed, because all the sides are the same, okay? Okay, so if I take the differential here, what would I get? I would get dv equals 3L squared dl. Then I would divide every differential by a dt. Hopefully you guys are seeing a pattern here, okay? Okay, so let's plug in what we know. I know that dv dt is 547. I know that L is 6 and dl dt, I could actually find out what that is, okay? So if you do this correctly, you should get, and this is where you guys should pause to try it out on your own, okay? If you wrote it correctly on your calculator, you should get about 5.0648-ish, but don't round just yet because it's not the final answer. And you're going to plug it back in here now that we know what dl/dt is. So if you did it correctly, ds dt will equal a rounded value of 364.667. Okay? Now, in terms of units, you're dealing with what, right? So think about it. S stands for surface area. So area is measured in square units. So in this case, I think they used centimeters. So it would be square centimeters per, in this case, time is measured in seconds. This means that the surface area is increasing since the value is positive at a rate of 364.667 square centimeters per second. Okay. Again, it takes a little bit of practice. Okay. It's kind of like a scavenger hunt. They give you all the values. You just got to find it. Okay. If you have questions along the way, just let me know. And we'll go from there. Okay.